Section 3, Video 2. Let's start by factoring out greatest common factors. Here we have a trinomial, and again our first rule should always be, do they have anything in common? And we're going to factor out the greatest common factor, and that means the greatest number that can go into all three terms. Now 2 can go into all three, but it would not be enough. We would have to factor out again later, and we want to be efficient. So we're going to look for the greatest number that can go into all three terms. In this case it would be 4. So if I divide each term by 4, it'll be taking out the greatest common factor. But also notice that they all have at least 2 n's. So that is its variable greatest common value or factor. So remember, we are dividing each term by 4n squared. And that's important to remember because what is our new term if we factor out 4n squared? Well, we would end up with a 2, and we took away 2 n's, so now we have 4. Remember, our exponents are subtracted in division problems. 32n cubed divided by 4n squared would give us 8, and we take away 2 n's, so it's just 8n. 4n squared divided by 4n squared, a lot of people would like to write nothing, but when something is divided by itself, we have 1. And the way to check that is if we were to redistribute, we should end up with the beginning term. Another question, here's a trinomial. The greatest common factor in this case would be a 10. A 10 goes into all three terms. They all have at least 3 m's, and they all have at least 1 n. So what's left if we divide each term by 10m cubed n? 70 divided by 10 is 7. We took away all the m's. We only took away 1 n, so it's n to the 6th. Notice it's negative 50 divided by 10, so we end up with a negative 5. We took away 3 m's, so now we have 3 left. We took away 1 n, so now we have 3 left. Again, 70 divided by 10 is 7. We took away 3 m's, and we took away the only n. And that is our factored form. Here we have a binomial, and when we say we had 2 terms, we should look at it closely to see if we have a difference of 2 squares. Well, at first glance we do not. But again, our first rule should always be to make the problem simpler, and that is to say, is there a greatest common factor? In this case, yes. 5 does go into both terms. So if I take a 5 out, I get 9k squared. 80 divided by 5 is 16. Now, a lot of people would stop here, but we have to always look at what we have for an answer. And what we've done is we've created a binomial that is a difference of 2 squares. So we are obligated to go further. And as we said, a difference of 2 squares is not too difficult to factor. The square root of 3k squared of 9k squared is 3k, and that goes first. The square root of 16 is 4, and that goes second. Now remember that it has to be it's a difference of 2 squares that we're factoring, so our factored form must have different signs. Does not matter which is plus or which is negative, they just must be different. So a good example of factoring out a greatest common factor, which allowed you to go further with what remained. Our last one, now 2 terms again, so we ask ourselves, is it a difference of 2 squares? We cannot root either one. It's not even a difference, so keep that in mind. But again, we should always at least ask ourselves, is there something in common we can factor out? In this case, yes there is. We can factor out a 3, and we get x squared plus 16. Again, we've created a new binomial. I can root x squared, I can root 16. But because it is a plus, we are done. We cannot go any further. And this ends Section 3, Video 2.